Hello class, so this is a video about the AC electric motor. This is basically a sequel to the magnetic effect of electric current. The link to that video will be in the description down below. I highly suggest you to watch that video before you watch this one. I will provide you a bit of a background to that video in this video, so if you don't want to watch that video, you are still fine. So let's move on to the actual background of this video. So an electric current exerts a magnetic force when moving through a conductor. This results in the conductor acting as a magnet and influencing other magnets. So this has been explained in detail in the first video. So basically what I want to say is that electric current actually exerts a magnetic force. It basically makes the conductor a magnet when it is moving through the conductor. The type of magnet depends on the the arrangement of the conductor and how the wires are placed together. That is basically the background of this video. And if you want to know more about the background, I suggest you to watch the first video. That's all you can do for now. Let's move on to the next slide. It is about the actual electric motor. What is this video basically about? So an electric motor is basically a coil conducting electric current placed between two magnets of placed in opposite directions. So in an electric motor, the coil is basically between the south pole of one magnet and the north pole of the other magnet. So basically the ends of these of this coil are connected to brushes, and the brushes are basically sliding conductors. Okay, the sliding conductors make contact with the actual wire, and the direction of the current changes as the coil turns. So as you can see, when the current is switched on, current moves from one side and it goes around and comes back from the other side in a traditional magnet, as you can see. But you know what? There's also a magnetic field moving from the north pole of the other magnet to the south pole of one magnet, right? So there has to be a force that is the outcome of these two forces clashing. Since there is a magnetic force exerted by the electric current, there's also a magnetic force moving from one magnet to the other magnet. There has to be a force, and the force is exerted in the upwards direction on the left side in the diagram. So let's revise. An electric current moves through the coil and comes back from the other side, and a magnetic force is exerted from the north pole of one magnet to the south pole of the other magnet. These two magnets are placed on other sides of the coil, and there is a force exerted as a result of these two forces clashing together, which results in one side of the coil moving upwards and the other side downwards. And in this way, the whole coil turns, and the coil basically switches sides, and the part which was on the right side gets to the left, and vice versa. So how do we actually determine the direction in which the force is exerted? Well, this is going to be expressed in explained in our next slide. The next slide is about Fleming's left hand rule. Using this rule, you can actually determine the direction in which the current is going to move. Basically, you need to know the direction of the magnetic field and the direction of the current, and that will determine the direction of the force exerted on the conductor. Okay, so if you position your left hand in such a way such that your forefinger, your middle finger, and your thumb are perpendicular to each other, as seen in the diagram, the forefinger should indicate the direction of the magnetic field, the middle finger will indicate the direction of the current, while the thumb indicates the direction of the force exerted on the current. Basically, that's how it works. For the first force to be exactly perpendicular in an electric motor, the condition is that the magnetic field lines and the direction of the electric current need to be perpendicular to each other, and then a perpendicular force will act on the conductor. So at the end of the day, guys, thanks for watching. Please leave any suggestions regarding my teachings in the comment section down below. Since I'm very new to teaching, I've become a bit more confident than I was in the beginning of my YouTube channel. Please leave any questions regarding the content of my video in the comment section down below. Please like this video if you learned something new from it. Please subscribe to my channel as I really need your support. Share this video with your friends and family. Thank you.